Hello and welcome to the new episode of Access Up Space, Defense and Security. And today we are taking a deep dive into CAVU Aerospace products. So the episode name is Engineering Excellence Behind the Technology Powering CAVU's Space Solutions. So we have had a lot of satellite operators, primarily even the ground station companies on this podcast. But hardly we have had any of the subsystem or the component level vendors on this podcast. So I believe CAVU is one of the benchmark companies which is kind of starting the trend of, where we'll be having more and more vendors from the subsystem and the component side telling us the story of the company as well as how basically the solutions are trying to make a difference in the industry, especially in the high demand markets like the new space. So without any delay, I would like to welcome Ali Mani. Hi, Ali. Welcome to the podcast.
Yeah. Hi. Hi. Thank you very much. Thank you for having me. Yeah, let's go.
Absolutely. Thank you very much, Ali. I know it's been quite a busy time for the industry. And as we are entering 2025, I think by the time we publish this episode, it will be already 2025. So I
Right.
believe it's a lot of things are going on, and I'm really excited to have this conversation with you down the questions that we have. I'll be, of course, taking a deep dive not into the kind of components that you have, but also how we are helping the industry basically kind of scale and uplift with the innovative solutions. So before we basically take a deep dive into that, can you briefly tell us about yourself as an individual? Basically, how did you end up doing what you're doing at the moment in the space industry?
Yeah, absolutely. Thank you very much. So the basically the I'm electrical engineer. I have the PhD in electrical engineering, and with the CAVU, the company background is pretty much based in aviation. Actually, they with the MRO service and overhaul for the avionics. So this is the company background. But because of the industry trends, aviation and space are always together. So um, with that background, we were receiving some inquiries for the electronic components of the satellites, and we ended up to manufacture the satellite actual electronic components. And yeah, so we just found ourselves manufacturer because of the some inquiries we were receiving, and then we actually, because we had this background, we participate in exhibitions and we were talking to the giants like FPGA manufacturers, and then we thought that it might be a good idea to have our own products. So we started with the onboard computing because of the some inquiries, and we developed some onboard computing solution for the satellites, launch vehicles. Satellite, I mean, sometimes big satellites, sometimes small satellite, and recently, because of the launch cost, CubeSats. So my opinion is that all this happening and this commercial space is much more affordable. All this is because of the Mr. Musk, and because of the launch cost is just going exponentially down and down every year. So we are actually in the market. We are seeing the trends, and we are seeing the volume of the inquiries is like more and more every week. So because of all this is happening, because of the launch cost and the commercial spacecraft or satellite is much more affordable than 5 years ago. So this is the industry trends, and we are seeing this is the place that we just ended up now.
Interesting. I mean, you mentioned about aerospace. I always tell people that several of the industries, including aerospace, is one of the, I would say, a prime industries, including along with that, if I can tag along defense, maritime, climate tech, and even media and broadcasting because of the satellite ground stations. So I believe there are several industries, which are kind of in line or aligned where space applications are very commonly used, or at least from a OEM side or a supplier side, there can be more and more expertise. So that's the reason also why we have launched the marketplace, which covers all the six industries, because I believe if there is an aviation player or if there is satellite operator who would like to, because their customers are not satellite operators, customers are not in the space industry. Your customers are in aviation, maritime. That's where people can basically procure your imageries. It's not the space industry who will be procuring your imageries. So I completely agree with you on that point, like how basically you gave us an outlook on from aviation, how we, kind of ventured out into the space domain. I think this journey can be also a benchmark for the emerging companies or the emerging countries where the companies are existing in the aerospace domain or in the maritime domain. They can definitely take a similar path and try to build on their expertise of the existing industry to get into the space industry. So that's an interesting point that you mentioned. Further
Yeah.
moving ahead into the conversation, could you give us an overview of the engineering principles that guide the development of CAVU's space and satellite products?
Yeah, absolutely. Actually, back to that point, this is the trend that I think the story happened to lots of the other giants. If you look at the Airbus profile of the projects, and how they switch from aviation to the space, also Embraer, we are working closely with the Embraer and some sub companies. They also were originally aviation, but because of the requirements or emissions defined in the countries, different countries, so they also ended up in this space. So this is pretty much same story happened to other people. But back to our products and our trends, actually because of our background and our electronic expertise, our main components that we are manufacturing is the onboard computer. And actually, basically, the company has three different sectors. One of them is electronic workshop. Let's say we are manufacturing the onboard computers and thermal control units and some transmitter and telecommunication for the satellites, ground stations, and the launch vehicles. This is the one sector, actually. That's kind of the sector that we are making money now. We have a big sector in next 5 years, I believe, but because of the so many commercial satellites now are planned to be in orbit, we are working closely with some giants to receive the space data, satellite imagery, the visible or hyperspectral, multispectral, and we are working closely with some, actually two universities, in University of Stirling and University of Strathclyde in Glasgow, to have solutions for the space data. What this is the sector we call it space data as a service, as you mentioned with the imagery. We are at the moment receiving the high resolution. I mean 30 centimeters resolution, multispectral or hyperspectral imagery from the giants like Maxar, Worldview, Planet, and the other companies providing that data. And we are working closely with some organizations to analyze the data and sell this as a service. For example, we are actually doing some preliminary geotech. Normally in the UK, when you want to do any project, you need to do topography, geotech, site survey, or biodiversity. You need to hire some companies, pay, depends on the application, like a
Yeah.
couple of £1,000 or up to £20,000 to have a site survey, to give you a topography or geotech survey, or the environmental assessment, or the ecologist will do that. So we believe that majority of these jobs, not as and nothing to do with precision. For example, for the topography, if you pay like £3,000-4,000, they will come to your site and give you a topography like scale 1 to 200. But most of the application, you don't need that precision. You can have the topography easily behind the desk and in a fraction of the time and a fraction of the cost with the space data, but the scale is 1 to 2,000 or 1 to 2,500, which is pretty much enough for majority of the jobs. Also for the geotech, also if you want to hire a geotech in Scotland, especially many islands, and you need to move your vans to the geotech survey, and it's minimum £15,000. But we can do it behind it is actually preliminary vision because of the hyperspectral imaging, and we have that kind of engineering and processing, image processing by counting the hyperspectral, and we have the idea that what is the water content or what is the rock type and everything. That's actually very interesting stuff we are doing after a couple of years collaboration with some students and some programs in the university. So we call it space data as a service, and our motto is that you can now, and also in the next few years, when everyone believes that many of the services that we can do it now, in future, or sometimes now, we can do it behind the desk with fraction of the time and fraction of the cost. So let's say, for example, preliminary geotech, topography, or the many services for the agriculture. For example, we have actually regular meetings with some agriculture sectors in Scotland and UK, This is programs actually funded by UK Space Agency and Space Scotland. You can have the water content of the potato underground from the space data. So this is actually amazing, but we have proof, have enough evidence that we can do that. Actually, many guys are working on that. So this is another sector. We call it space data as a service. And the other sector is actually the aviation and MRO, which is original business. So we are the certified MRO with a very limited capability list, actually focused on avionics. This is the three sector, but most of our energy team and the resources is still with the first sector, which where we manufacture of the satellite components, onboard computers, and depending on the demands. Mostly we are listed in the platforms, or we listed our products with the heritage and very much details information about the technical specification, interface, heritage, and stuff in the website or the other platforms. And clients, when they have a project and they see, okay, this is 50-60% matching their mission requirements, so they approach us, and normally our engineers will talk to them for few months sometimes, and then when all the technical discussion is closed, then place the order with us and we deliver the job. We provide the full documentation according to ECSS standard during the projects, whether it's a product or a project. And because we are based in UK and we're just like half an hour driving from the Higgs Center, which is actually UK STFC, Science and Technology Facilities Council, we are listed there. We have account there in many of the test facilities. So we provide the full solution from the design and also the all the project duration. We communicate closely, sometimes weekly basis with the clients. We provide the full project documentation according to the ECSS. We provide the test services, in-house engineering, in-house functional tests, and we deliver the job. This is how we are making money.
Interesting. I really got interested, especially with the space data part. Coming from academic background of bachelor's in geology, I my path toward the space industry started with that. So I actually did on ground during my bachelor's all the geoengineering, especially in the civil engineering domain. We used to go with all those topographic instruments, where how the people used to possibly try to level the try to measure the levels of the lands when it comes to the land feelings, and try to spot the minerals and everything. I agree with that fact, because later on in the final year of my bachelor's, I took my specialization in satellite and remote sensing, and I got to know, how things, the processes are so much easier. So I can very much relate to that solution that you mentioned. And going a step ahead, as you mentioned about your products. So, what are the key features of CAVU's flagship products, and how do they address challenges? Or, I mean, I would say, how do they firstly address the unique demands of the space mission, and how do they also kind of, I would say, are solving some of the biggest challenges in the space industry?
Yeah, actually the core business is the onboard computing, and the three basic things for this onboard computer, or let's say OBC, is reliability, modularity, and a bespoke design. Like I said at the beginning, when I look at our profile since 2016, we just had a single OBC designed for a special mission. But then after because we are working closely with the FPGA manufacturer, and because of some demanded missions or requirements. So now we look at the profile and we have the OBC1, OBC104, or the more advanced FPGA architectures like CDHF1 or CDHFS. So basically, they were actually building everything from the scratch based on a specific mission that they approach us with their requirements, and we did the design. So, but always we provide with the very high reliability. We provide the FMEA for our products based on the mission. We actually supply them with the documentation, with the ECSS reliability document, CIL, and everything. So reliability basically is the most important things in the design. Modularity, again, because of the nature of the business, space missions are incredibly diverse, ranging from LEO to the deepest space. So that's another point that we always need to take account, and also bespoke design now. So mostly this is why the technical discussions actually last for a long time, And when I see the profile at the beginning, some actually recently, we have a product which is let's call it a feature product. It's OBC Polar. Mostly when the clients actually approach us with the OBC One or OBC 104 or a frame grabber, it's another component that we have. When we talk to them, actually we go deep into the technical discussions when they see the other products. So mostly they switch from other products which we developed in last few years to the OBC Polar. This is all because of this is the microchip latest developments with the IC. So back to the same point, the bespoke design, and because we have everything in house, we can easily make bespoke design for the mission requirements, whether it's the input, outputs, interface, or anything. So this is actually very normal for us. That's why it normally takes months and months before we close any order with the client. So basically, also we have, for example, we have recently a project with one of the space giants with a very big Earth observation satellites. We provide them the thermal control unit, which has the inputs, I think, 110 sensors, and output is like more than 50 heaters. So you can imagine how big is that TCU. We call it TCU, thermal control unit, and the data sheet and some basic information is available in our website. We designed from scratch based on the mission requirements, and this is actually I think, as far as I know, this is the most advanced solution for the thermal management in a satellite. We built from scratch based on emission requirements. I think it took like 4 months to close the technical discussions before we get into the order. And when the order was placed, that was 6 months design and the testing, functional testing, EMC testing, and all the other testing took 6 months for us to close everything with the client. And most of the times, if the clients are not pushed because of the time and scale of the project, then we can have much better solution for them. Yeah, this is actually very routine jobs for the CAVU engineering team.
Interesting. That's a quite a hefty process. I think you walked us through the complete design process, and I would say briefly also touching up the part of the concept to final deployment. And actually coming to the part of actually technology, because you mentioned about the technical stuff. So what proprietary technologies are integral to CAVU's products, and how do they enhance performance in space environments? For example, you mentioned some of your flagship products like OBCs. That is something that you manufacture on a large scale. So what is the proprietary technology underlying over there? I mean, if at all you can share.
Actually, it depends on the project. Engineering for the space and satellite sector, presents unique challenges. At the CAVU Aerospace, we are tackling one of the biggest challenges, which is always, if it is we are actually, let's be more practical. We are talking to a project which is deep space, 80,000 kilometers, and the power demand of that thing and the space would be something like 3,000 watts, and we are providing the power solutions and onboard computer. So you can imagine with that harsh environment, we need shielding. A lot of stuff is going on there. So because again, back to the original point, because we have the in-house engineering, that we need to tackle all these issues, the FPGA and system on chip. This is what we are doing now. Inherently immune the radiation induced single event upsets, and incorporate redundancy of the fault tolerant design. So for that one, when we are dealing with that kind of the projects, we need to review everything from scratch. So we are actually in this business since 2016. Practically, we have our own supply chain and stuff, so we know exactly when this is the challenge in a project. We know how would be the lead times, but as far as I know, our lead times is relatively low to when it's especially with the higher ed products. So
Yes.
that one is actually where we have actually the most of the competitiveness in the time and the cost of, because of our background in engineering and the product. Just look at profile of the products, and you will see that which kind of jobs. So normally, when we talk to the clients, when they approach us with the specific requirements, we would be able to share after some NDAs and stuff, and then they just would be very selective. And we have normally, when in the actually receiving inquiry, we have many things to share with the previous projects, whether it's a Leo or a launch vehicle or with the deep space. But we have actually a spectrum of the projects, from the launch vehicle, Leo, small sat, big Earth observation satellites, or some exploration funded recently, I mean, last couple of years by UK Space Agency for that orbit. So this is happening almost every month.
Interesting. I would say that an extended overview of the things that you mentioned. And coming to the part, little bit zooming out from the technology discussions and coming to the main part, I think this is where most of the industry and even I personally get scared sometimes, because I think regulations, bureaucracy, standardization, I think this is very much important, because I think space is a very sensitive industry when it comes to national security and all, because the prime customers are from the defense sector and governments as well. So from that perspective, how does CAVU ensures that its products meet industry standards and regulations for space operations? Because I believe the kind of demand that we are seeing in the industry, it's quite different than what it was 10 years ago. I mean, we are no more manufacturing traditional geo satellites. I mean, there are geo satellites being manufactured, but not to a scale which earlier the satellite operators used to. Now things are moving towards more of a small satellites or micro satellites. From that perspective, how do you ensure the that your products meet standardization and regulation aspects in the industry?
Yeah, on that point, I think we should have an interesting topic, because normally, because of the ECSS standards, that gives a bit feeling of the conformity for the clients, because we go through every single step in the design to materialization of the product. We have always conceptual design, preliminary design, and detailed design, testing, qualification, and certification before the production, right? And this is normally weeks and months for some projects, and in every single step we share information very openly with the clients, and their engineering times actually sometimes take weeks for them to comment and review and to approve a document, and then we get into the production and the integration. So normally this actually gives a level of the confidence with the clients. But other than this stuff, we had actually discussions with the reinsurance companies actually since last year. Some of them actually are actually leaders in the industry, global industry of the insurance. They provide a specific insurance packages for the aerospace, especially. I'm not sure if you heard of it, but we are talking to some giants. I don't want to mention the names, but actually there is a couple of the industry giants that we are talking, and we to be honest, we haven't actually provided a reinsured product yet because of the rate. So, but just give you some idea that how would be the rates, because they need to ensure actually the scope of the work that they can do. If the clients ask, normally our normal procedure with the conceptual design, preliminary design, qualification, and certification. So gives confidence of their level of the reliability, because we gave them the full FMEA reliability CIL documents before production, and they have any idea how many nines is in our reliability of the component, whether it's subsystem components or a whole solution, because we also sometimes provide the platform solution. But other than this, it sometimes, because the mission is critical or the level of the damages is too high. So there is some reinsurance, we call it reinsurance packages that we are providing for the clients, but no one picked up. So the rate of the reinsurance depending on the scope of the work that is covered by reinsurance. And just to give you an idea, for some case it was a low failure rate or likelihood that was only 4% of the mission. But there was a deep space and the with high level risk, and the rate was 13%. So let's say up from 4% to 13% of the scope of the work. This is the rate of the insurance that if a client is happy to pay to have this reinsurance, we are happy to provide. So this also takes a lot of the considerations and the parameters and studies, risk assessment. So I remember that we provided, I think, more than 7 documents to the insurance company, but potentially we have that in our scope of the services or products.
Interesting. I think you also briefly covered the part on how the clients can basically tailor the solutions according to the mission requirements. Because I believe courts doesn't really exist in a full-fledged manner in the space industry. We work as per the mission requirements. I think previously also you mentioned in few of the answers. So I'm glad that you, along with the regulations, you also covered that part. I think we are almost at the end of the episode. So this is the final question. I would say answer it the way you feel it and what you're looking forward to, and the kind of progress that you're doing. Of course, if there is any confidentiality, you don't have to speak about those kind of project, but I'll completely leave this kind of grip on you to how to answer this question. So looking ahead, what are some of the engineering developments on the horizon at CAVU that could redefine the future of space operations?
Yeah, that's again interesting point. Because of the nature of the business, and we always have to keep ourselves updates, and most of the times, because the project time scale, is sometimes 2 3 years, and sometimes they approach us and they say, oh, can we have the OBC in the next couple of months? So there's always a no, but majority of the project, the time scale actually allows us to have the latest development and updates. But just to be practical, give you an example, we are working with closely with as a design partner, one of the FPGA leaders in the market, and they actually shared information with us. We have early access to some FPGAs which will be available commercially 2026. So if this is not in place, so normally the FPGA is commercially available 2026, then we can use that in satellites in 2028, which on that time, these existing solutions, like whether it's OBC Polar, OBC One, or OBC 104, none of them is going to work because of the project demand. We are seeing this. Some OBC that we designed and that was actually the edge of the technology a couple of years ago, no one is actually placing any inquiry for that. That's actually the speed of the industry. This is the actual nature of this business. So we understand the situation. We totally understand the project demands and the missions, time scale, budgets. This is a commercial space. This is not a state-owned business. So this is getting much more commercial than last 5 years. So we have to be competitive, whether in time, technology, and the costing. So to cover that, we are actually working closely with the FPGA manufacturers, and they provide the early access to us. We are actually helping them in a design and stuff. So we are design partner for few of them, and to cover that demands, we have early access. We are at the moment we receive the hardware, software packages, and we are working on that. So if you look at the website, we have a section, we call it OBC at the moment, OBC for 2026. And we have 3 products under development, almost finished with everything. And this is based on the FPGAs, which are not commercially available now, not next year, but next 2 years. So this is actually, I think this is very normal for us because we have done this before with the Texas Instrument or the microchip or whatever. So, but now to cover that demands, now we have that section in our website. And if there is interest, so client just approach us and they are in touch with our engineers. We share interface requirements, project requirement, data rates, and everything. And this is actually very practical now and very usual for us, getting to be very usual for us. We have OBCs for the 2026 based on FPGA to be commercial at that time. So this is very much, and you can imagine how is the trends and requirements of this industry.
Amazing, amazing. So yeah, all the vendors on our platform, please take a note of this. There are new products coming from CAVU, and please feel free to send us the sales leads on Access Hub. The products are under development. So of course, you can get the orders from 2026, not from next year.
Yeah,
So yeah,
actually,
thank you.
if you go to the website, you can see a section OBC for 2026. Some basic information is shared.
Yes.
on that the website. But if they approach and we sign NDAs and everything, we can share more information. And yeah,
Absolutely.
that's this nature of this business. Yeah.
Absolutely, absolutely. No, I'll be adding this information as well in the podcast description when we publish it. So yeah, thank you very much, Ali, for providing such valuable insights into the company, your business, your current products, as well as what the future looks like for the CAVU. So I hope to see you again on the podcast because there is a lot to discuss. We haven't really taken a deep dive into your products and services. I think next time we would like to do that with kind of use cases because people very much relate in the industry when you give them an example of an use case related to your products. So yeah, thank you very much. It was great to have you on the
Absolutely.
podcast.
Thank you very much. I appreciated your time. I think next time we will have much more to show about the space data and how we can
Yes.
actually materialize something that we just pointed this time. Yep. Looking forward. Thank you very much, Monka.